a two-digit example of what we're trying to find today. 4 consecutive composite numbers. So 24 is composite, it's divisible by 2. 25 certainly composite, divisible by 5. 26 divisible by 13 and 2. And then 27, of course, is divisible by 3. So we have 4 consecutive integers that are what we call composite. Yeah, what do we mean by composite? Let me just write down kind of a simple, I like this definition quite a bit right here. A number is composite if it has a divisor, shall we call it D, that's strictly greater than 1 and strictly less than the integer. So in this type of n that you see right here above the word composite is the definition of composite. Okay, that's little d for a number between 1 and its, and you see this satisfies it right here. Now we're looking for 4 consecutive 6, okay, and that's tough. Okay, it actually was kind of hard for me. Think about it. Try to find the next 4 consecutive composites. Try. 28, 29 doesn't work, right? 41 doesn't, you know what I mean? It's not so easy to find just 4 at the 2-digit level. We need to find 4 at the 6-digit level. Now, to our rescue here, and this is I would call this the hardest part of the problem, to know what the value of 9 factorial is. Now, you can do this manually. I don't know if competitions would allow you to use a calculator on this or not. I'm not sure, because it doesn't really, you still have to know some other things. But this is a 6-digit number. It's 362, 880, 362,880. Okay, so that's certainly 6 digits. Now, another very, very useful thing is that 9 factorial is congruent to 0. I mean, it's obviously a multiple of 9, right? So it's congruent to 0 mod 9. Okay, so that's nice. Now, so what are we looking for? We want 4 consecutive 6-digit composite integers. Well, we're looking good because we do have a 6-digit number that is leaves 0 when it's divided by 9, right? A remainder of 0. We want one whose sum is 5 modulo 9. So let's move along. Now, this is the so-called discovery right up here. Through some discovery, we are motivated to consider these 4 consecutive numbers. Now, the cool thing about this is we already know that 9 factorial is a 6-digit number, right? So this number, this very first number here, is certainly divisible by 2, because 2 is a factor in 9 factorial. 3 is also a factor in 9 factorial, so on. See, we could have made this longer if we wanted to, right? Well, wait, maybe this condition about the remainder of 5, though, is kind of a slowdown here. Okay? So we've taken care of the one part of this. This is 4 consecutive, clearly 6-digit numbers, right? Adding 2 to this would make this 882, 883, and all the way down the line, right? Okay, now what about the whose sum is 5 modulo 9? Now, in plainer language, that means when you divide this number by 9, you get a remainder of 5. Okay, so let's write down what this is equal to. This is equal to 4 times 9 factorial. Okay, now plus we have to add up 2 plus 3, that's 5, plus 4 is 9. That already would be 0, right? So, but I'll just go ahead and write down 14 for the sake of being complete here. All right. So that's equal to 14. Now, although you can just see it in your head at this stage. Now, this part is clearly congruent to 0. This is congruent to 0. Any multiple of 9 leaves no remainder, right? When you divide it by 9. Okay, so you get congruent to 0, and then 14 is congruent to 5. Okay, and that's modulo 9. Notice how the equal became congruent, and so we have to designate the modulus, which we all know. That's mod. This marker's starting to crap out for some reason. Don't know why. Okay, y'all, that's supposed to be mod 5, and that's a bastardized M right there. Sorry, this proves it. we are finished. And again, the modular arithmetic it supplants a very enormous calculation if you didn't have modular arithmetic at your disposal. Okay, and that's what we were looking for. Now, if you want to take the time, just technically you might say, well, you didn't write the numbers down. Well, yeah, I don't like to, because I don't like to write with this mouse. But this is 362. What, 882? Right? And so on, folks. So this is a 6-digit number, 362, 882. This would be some 6-digit. This would be 883, 884, and 885, right? So we got the job done. The 4 consecutive 6-digit composite numbers that leave a remainder of 5 upon division by 9. And by the way, this part, one of the reasons this works out nicely, and I'll just write it up here, is because 10 raised to any natural number power is congruent to 1. Congruent to 1 modulo 9, folks. And when I say n has to be a non-negative integer. If you have a negative integer, this would be a fraction, right? But this reads 10 raised to the nth power is congruent to 1 mod 9. That means all the powers of 10 go away. And this is the whole basis for the casting out of 9s and all of that, you know. So anyway, the 10 raised to the n is congruent to 1 mod 9. It's crucial. It's similar for modulo 3 too. But anyway, that's done. We're done, folks. We're finished. Thank you for being.